9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour.
Hello, I'm Dale Lear. Model rocketry has been one of my favorite hobbies for the past 25 years. Displayed here are several model rocket kits, a launch pad, and a launch controller. Model rocket kits are available in a variety of sizes and are for differing skill levels. In this video, you will see several different styles of model rockets. I will discuss how they operate and safety when flying your model rockets. I will build a couple of different types of rockets, and you can even watch several launches. This rocket is not a flying model. It is used to demonstrate the parts of a model rocket. On a flying model rocket, the nose cone is made of hollow plastic or lightweight balsa wood. The nose cone is aerodynamically shaped to provide the least resistance when the rocket is traveling through the air. The body tube is a hollow, lightweight paper tube that is the main structural part of the rocket. The fins keep the rocket flying in a stabilized manner, much like the feather fins on an arrow. Inside the rocket is a recovery device that allows the rocket to return safely to the ground. There are various types of recovery devices that we will discuss later in this video. Recovery wadding is a flame-resistant paper that protects the recovery device from being damaged by the ejection charge. The launch lug is a small tube attached to the side of the rocket. This tube slides over the launch rod on the launching pad. This rod guides the rocket until it gains enough speed for the fins to keep the rocket stable. The most frequently used recovery system is the parachute. The parachute is usually made of plastic, but cloth can also be used. The parachute is attached by strings called shroud lines. These lines are attached to the shock cord which connects the nose cone to the body tube. The parachute slows the descent of the rocket so that it returns safely to the ground. The next most popular recovery style is by use of a streamer. The streamer is usually made from flame-proof type of crepe paper, but plastic is also used. A rocket with a streamer will descend much faster than one with a parachute. If you are launching in a small field, this can be very helpful because the rocket will have less time to drift out of the recovery area. If you are flying in windy conditions, a streamer can be a good choice to keep your rocket from being carried far away. Keep in mind that a heavier rocket could be damaged by a faster rate of descent. You can make your streamer longer or wider to slow the rate of descent, or you can use more than one streamer. If it is a windy day, you should launch your model rockets into the wind. This drawing demonstrates how the launch pad should be tilted into the direction of the wind. The rocket will travel far away from you, but as the recovery device deploys, the rocket will travel back toward you. You should not fly model rockets in winds of more than 12 to 15 miles per hour. This is a greatly enlarged drawing of a model rocket motor. The motor provides the thrust that propels the rocket into the air. It also provides the method of ejecting the recovery device. The motor is factory made, and you should never attempt to reload or alter the motor in any way. The motor casing is made of tightly wound paper. It is strong, fire resistant, and does not conduct heat easily. The nozzle is made of a ceramic material that directs the thrust of the rocket motor. The propellant is a solid propellant that when burning produces hot gases that escape through the nozzle. This escaping gas produces thrust to propel the rocket. When the propellant is burned up, it ignites the time delay. This time delay does not produce thrust, but it allows time for the rocket to coast upward to its maximum altitude. The time delay also produces smoke, which makes it easier to track the rocket at high altitudes. Once the time delay is used up, the ejection charge is activated. The ejection charge produces a quick puff of gas that pops off the head cap and pressurizes the body tube, which pops off the nose cone and ejects the recovery device from the body tube. The recovery device allows the rocket to return slowly and safely to the ground. The power of the rocket motor is determined by the force multiplied by the length of time that the force is applied. The force of a rocket motor is its thrust. Thrust is measured in metric units of force called newtons. 1 pound of force equals 4.45 newtons of force. A model rocket motor producing 10 newtons for 1 second has theoretically the same power as one that produces 5 newtons for 2 seconds. Newtons of thrust times seconds of duration is called Newton seconds. The total impulse of each type of rocket motor is found by multiplying its thrust by the thrust duration. 10 newtons times 1 second gives us 10 Newton seconds. Also, 5 newtons times 2 seconds gives us 10 Newton seconds. Theoretically, both of these examples will take similar rockets to the same altitude. By looking at this chart, you can see that each successive rocket motor has twice the power of the previous motor. A 1/4 A motor has half the power of a 1/2 A motor. An A motor has twice the power of a 1/2 A motor. This progression works through the entire chart, with the D motor having twice the power of a C motor. This is a launch controller. There are 4 AA batteries inside. This provides the power that causes the igniter to fire, which in turn fires the rocket motor. If you want to test your launch controller, you can attach the 2 clips to each other and insert your safety key. Now, if there's a good connection and your batteries have power, the light will light. This drawing shows how the launch controller works. The batteries provide the power. The power travels through the contacts to the base of the bulb, then up through the bulb's filament and out through the side of the bulb's base. Provided that the key has been inserted, the power continues through the key to the wire which leads to the igniter. The power then travels back to the other side of the wire and to the batteries, completing the circuit. The bulb causes enough resistance to keep the igniter from firing. However, when the launch button is depressed, the power bypasses the light bulb and travels full power to the igniter, causing it to fire. If the light bulb is burned out, the circuit is broken and the rocket motor still would not fire. However, if you depress the launch button, it will fire the igniter because it bypasses the bulb's circuit. Igniter is inserted into the rocket motor. We then bend the igniter over and tape the igniter to the rocket motor. When the rocket is placed on the launch pad, be sure that the safety key is not in the launch controller. Check to make sure that the igniter is not touching itself or anything else which may cause an electrical short, which would cause a misfire. When you are sure that all of your connections have been correctly made, remove your safety key from the top of the launch rod and proceed to your launch controller. Everyone in the area should be aware that you are about to launch your model rocket. Check closely to be sure that there are no aircraft flying in the vicinity. Next, you insert your safety key into the launch controller. If the light does not illuminate, you will need to recheck all connections. If you have a good connection, the indicator light will burn. Let's get started building one of our kits. Our first kit is a real simple kit. It's designed for a skill level 1. That's considered a good beginner's kit. Before you begin, you should read the instructions all of the way through. Be sure that you understand them completely. This can prevent a lot of trouble later. This is a kit from Estes Industries. My first kit more than 25 years ago was from Estes. You can count on them to provide complete and easy to understand instructions. They have a great assortment of kits available. All of their kits are rated into skill levels. You should start with a skill level number 1 and then progress to a skill level number 2 and so on. This is our first kit. It consists of a body tube. We've already cut out the fin marking guide and placed it around the body tube. A nose cone, 3 fins that are pre-cut, and a launch lug to guide the rocket along the launch rod. First, after you've wrapped the fin marking guide around the rocket, you need to mark where indicated. This shows placement of the fins. Now we're making a mark top and bottom for each of the 3 fins, and then we'll connect the 2 lines to make a straight line. You need to be very careful when lining up the dots to make sure you get a straight line between them, and our fins have to be lined up in line so that they're not crooked this way too. After we get the lines on, we'll check our fins to make sure that they're straight. And we'll go ahead and mark the other 2. Be very careful to get them straight. Okay, the next thing is in preparing our fins, we need to sand the rough edges. We can put the fins all together at once, line them up. We can just sand the edges like that, make sure that they're smooth. Be careful not to rock them from side to side or around the edges of the fins. This sanding just takes some of the rough edges off. Okay. Okay, next we'll attach the fins to the body tube. Now these fins are pre-cut. You see the grain of the fin runs this way, so that when it's mounted on the body tube, the fin will be very strong. If the grain ran this way, when it's attached to the body tube, the grain running this way would make it very weak, so a little bit of pressure on this would cause it to snap. Okay, let's apply a little glue. And attach our first fin to the body tube where we've marked. Now we'll hold that on there for a few minutes and make sure that it's dried, and we'll check to make sure that it's aligned properly as well. You can make sure that the center of the line comes up the center of the fin, and the center of the back of the fin is matched up with the line as well. Okay, our first fin is dried in place, and we've checked it carefully to make sure that it's lined up, centered. Now we'll attach the other 2 fins using the same method. Okay, we've attached all 3 of our fins and they've dried. Now you want to make sure that you have 120 degrees from fin to fin. That makes sure that they're all lined up properly. Next, we'll run a bead of glue alongside each fin on both sides to give it extra strength and make sure that it's attached really well to the body tube. As this bead of glue starts to set up, we'll add a little extra glue along the side of one of the fins, and we'll place our launch lug against that. Now we need to make sure that our launch lug is running parallel to the body tube so that the launch rod can give the rocket a good straight start. Now while that's drying, we can run a bead of glue around the inside top of the body tube. And we'll insert the nose cone. Okay, now we need to hold the rocket steady until it dries, but when the glue dries, it's ready for finishing. Okay, this is our next kit. It consists of a body tube, engine mount, shock cord, nose cone and base for the nose cone, launch lug, die-cut fins, the fin marking guide that we've already cut from the instructions, and an engine placement guide, or a motor placement guide. Okay, the first thing we'll do is mount the engine mount, or the motor mount. Now we need to measure up 1/4 of an inch from the bottom of the engine marking guide. Okay. Now we need to make sure that it will go in the body tube. Now we'll place the glue up in the body tube and make sure that it goes all the way around. Next we'll insert the motor mount, and with the motor mount or engine mount placement guide, we'll slide the motor mount up to where we have 1/4 of an inch sticking out. Now you want to be sure and remove this placement guide because there will be glue on it and you don't want to get it caught up in there. Okay, we'll let that dry. While that's drying, we can be cutting our fins out. Now, I think you can see there that the fins are already die cut, and all we have to do is trim them out. We'll just use our X-Acto knife and follow the lines that the die cut has made. And you should be able to pop the fin right out. We'll continue with the next fin. Just go right on up the edge and that'll get rid of that piece of balsa wood. Sometimes these fins pop right out, but you need to be very careful to make sure that you get them out clean with no breaks. Sometimes the fins are cut nicely, and other times you have a lot of trimming to do to get them loose. Okay, now we'll use our sandpaper. I always like putting the 4 or 3 fins together and smoothing them all at once. It seems to be quicker and gets them sanded a little more evenly. Again, you have to hold the fins very flat as you sand them so you don't make any of the edges rounded. These fins were die cut nicely, so they don't need much. Now again, you have to watch the grain in the fin. You see the grain runs this way. If you would mount the fin like this, the rocket would probably fly, but the fin would be very weak because it would tend to break if anything put pressure against it. So you see here, this is the proper way to mount. See, the grain runs this way, and it gives a stronger fin that way. Okay, now we'll wrap our fin marking guide around the body tube, and we'll find where we want the fins to be. Wrap that all the way around like that. Get it lined up good and straight, and then tape it. Now, one way to make sure that the marking guide doesn't move is to take a small piece of tape and attach it like that so that it doesn't turn. Now we'll mark the top and the bottom for where the fins should be. Now in this model, there's a place for the launch lug. So I'll put a little L here to be sure that I don't accidentally try to place a fin at that mark. When you get the marking done, you can remove the marking guide, and we don't need it any longer. Now be sure that you're following your instructions. You should have read through the instructions thoroughly to make sure that you understand. Okay, now we'll place a little bit of glue on the root edge of the fan. It's called the root edge because it fits against the body. Now I like to put a little glue on the couple of the fins and let it get tacky before I put them on. It seems to be easier to hold them as they start to dry. Just be sure that you don't put them somewhere where they'll get stuck to something and you can't get them loose. Okay, now our marking guide was real narrow this time, so we don't really have to draw a line between the two indicator marks. We can just place the fin so that it runs between the two, and if the base and the top of the fin are lined up, then we'll be in good shape. Now I like to hold the fin steady until the glue starts to dry. And as it starts to dry, make sure that the fin runs perpendicular to the body. Okay, we've attached all 4 of our fins, and we've also attached the launch lug. Now this rocket has 4 fins, so they'll run at 90-degree angles with the launch lug right in between 2. Now they've just started to set up good, so we'll run the extra bead of glue along each side of each fin and also each side of the launch lug to strengthen it. Now, one thing that I didn't mention, but it's just common sense, make sure that this is the end that you put the engine mount in. It should be about right up here. If you put it in the other end, the engine mount will be all the way up here. And when the engine fires, or the motor fires, it will shoot all the way up through here, and it'll throw the rocket off balance, and the thrust from the engine will burn the bottom of the rocket. So be sure to pay attention to what you're doing when you're building your rocket. Okay, the glue on our fins is starting to set up pretty well. So next we'll insert the shock cord. We'll go down about 3/4 of an inch and cut one slit, and then down another 1/2 inch and cut another slit. Then we insert the shock cord. We have to make this a little wider. We'll pull the shock cord out the end. Down that far can be kind of hard to get a hold of, so we'll use our ink pen to pull it up. Okay, and next we'll tie a knot in the shock cord to keep it from coming back through. To add a little glue to the knot so when we pull it back through it sticks. Okay, then we'll take the other end and run it through the other slit. And pull the cord out again. Okay, while our shock cord is drying, we can attach the other end to the nose cone. We'll pass it through the base of the nose cone and tie it in a knot. We'll add a little bit of glue to the knot just to help it keep from coming apart. I'm going to make it easier to get the nose cone back in the rocket. I'm going to trim off the end of this extra shock cord here. Okay, the next thing we do is glue the nose cone to the base of the nose cone with plastic glue. Okay, this rocket is ready to finish and then fly. Now this is a small lightweight rocket, and has no recovery device such as a streamer or the parachute, when the ejection charge pops, it blows the nose cone from the body tube, and it being unstable but yet such light weight will cause it to drift slowly back to ground without harm. Okay, we've completed the construction of both of our model kits. As soon as the glue dries a little more, they're ready for finishing, and then they'll be ready for launch. You should carry to every launch a range box. Your range box should include recovery wadding, spare parachutes and streamers, spare shock cords, a razor knife, masking tape, quick setting epoxy for fast repairs, extra batteries, electrical tape, and of course plenty of motors and igniters. Over time, you will think of many other items that you will want to take with you. Your range box can be a fishing tackle box, a toolbox, or if you wish, just a plain cardboard box. Let's discuss the model rocketry safety code. First is construction. My model rockets will be made of lightweight materials such as paper, wood, plastic, and rubber without any metal as structural parts. 2 is engines. I will use only preloaded factory-made model rocket engines in the manner recommended by the manufacturer. I will not change in any way nor attempt to reload these engines. 3 is recovery. I will always use a recovery system in my model rockets that will return them safely to the ground so that they may be flown again. 4 is weight limits. My model rocket will weigh no more than 453 grams, or 16 ounces, at liftoff, and the engines will contain no more than 113 grams, 4 ounces, of propellant. Number 5 is stability. I will check the stability of my model rockets before their first flight, except when launching models of an already proven stability design. Number 6 is launching system. The system I use to launch my model rockets must be remotely controlled and electrically operated, and will contain a switch that will return to off when released. I will remain at least 10 feet away from any rocket that is being launched. 7 is launch safety. I will not let anyone approach a model rocket on a launcher until I have made sure that either the safety interlock key has been removed or the battery has been disconnected from my launcher. 8 is flying conditions. I will not launch my model rocket in high winds, near buildings, power lines, tall trees, low-flying aircraft, or under any conditions which might be dangerous to people or property. Launch area. My model rockets will always be launched from a cleared area, free of any easy-to-burn materials, and I will use only non-flammable recovery wadding in my rockets. 10 is jet deflector. My launcher will have a jet deflector device to prevent the engine exhaust from hitting the ground directly. Launch rod. To prevent accidental eye injury, I will always place the launcher so the end of the rod is above eye level, or cap the end of the rod with my hand when approaching it. I will never place my head or body over the launching rod. When my launcher is not in use, I will always store it so the launch rod is not in an upright position. 12 is power lines. I will never attempt to recover my rocket from a power line or other dangerous place. 13 is launch targets and angle. I will not launch rockets so their flight path will carry them against targets on the ground, and will never use an explosive warhead nor a payload that is intended to be flammable. My launching device will always be pointed within 30 degrees of vertical. 14 is pre-launch test. When conducting research activities with unproven designs or methods, I will, when possible, determine their reliability through pre-launch tests. I will conduct launchings of unproven designs in complete isolation from persons not participating in the actual launching. Be sure to watch for our second volume on advanced model rocketry. In it, we will discuss designing your own rockets, multi-stage rockets, payloads, altitude tracking, glider recovery, and my personal favorite, high-powered rockets like this one that is propelled with a G-size engine. And there will be more exciting launches like this one.
3, 2, 1, ignition!
I hope you've learned from watching this video, and I hope to see you again real soon. Thank you.